can, yes.
So what about when zeta is between 0 and 1? It's also
Yeah.
going to be stable as well, right?
Yeah.
Oh, yeah.
Yeah.
Okay, cool.
I'm waiting for almost there. How about the zeta negative? Oh, what's this? We haven't seen this before. And let's look at this one, discuss a little bit faster. Okay, so zeta is less than 0. Basically, that situation is something like this. Let me make one example here. Let me make a good one. Okay, just make this one. Okay. So for this case, we can see the root. And 2a minus b plus minus square root of b squared minus 4ac. So we can do a little bit calculation. 2 plus minus and 4 squared, that's minus 4. So that is 2 plus j cubed, and that is 1 plus j1. Okay, so like this one. So for this case, we see. So for this one, the locations of this root is on the complex plane, and right now it is on this side here. So basically this is 1, this is 1, minus 1. So here and here. That's the location of the roots. Okay. And again, these roots have the same patterns like we did before. The x of t will be equal to, that's confined by the exponential in profile, and the profile is governed by the real part. For this case, it's 1 times t. So that is t. And capital X, and then cosine. And oscillation, again, is confined, is regulated by the frequency that's defined by the imaginary part. So that's t minus c. Okay, so for this case, its time domain representations will be like this, corresponding to this one. Right now we have this exponent, and that is the math equation that is increasing over time. And these are oscillations. So the frequencies, again, here is 2 pi divided by omega d, and here omega d equal to 1. So frequency is 2 pi. For this case, the damping ratio is negative. That will cause system to be unstable. Unstable, that means the value of the xt, and eventually that's going to go to infinity. So for this case, this is defined as the unstable systems. Okay. And here I make an example is the negative damping. And in concept, they could have also negative spring constants, negative equivalent spring constant as well. That might likely make the system unstable. And when will be the situations we will see in concept the negative spring constant. And we can look at one example. Basically, that is they call it inverted pendulum. What is that? Like this one. Basically, you can see this system, by its nature, is unstable. And I make that stable is because I make an active control of the base to make that stable, right? So, but this one, this system by itself, is called an unstable system because we can make that stable and just stay standing there. But initially, if we have any little perturbations, that perturbation will make system go to disaster, won't uncover his initial status. That's called an unstable system. Okay. So for this case, we can take a look at this example here.